Okay children, today's question will be: a ball having a charge q and mass m is suspended from a string of length L between two parallel plates where a vertical electric field E is established. Find the time period of the simple pendulum. So what have they asked you to find? They have asked you to find the time period of the simple pendulum. Okay, right? The charge of the ball is q and mass is m. Okay, right? They have asked you to find the value for the time period of the simple pendulum if electric field is directed downwards and upwards. Okay, right? So first of all, let's draw the diagram for this one. So what have they told you? They have told you that there is an electric field applied for the system. Okay, right? So let these two be the plates to apply the necessary electric field. Okay, right? I'm not putting which is positive, which is negative, children, because they have asked you, they have told you that if the electric field is directed downward, so in the first case it is going to act in the downward direction. So when it is acting in the downward direction, you know that the field will be always from the positive to negative. So in the first case it will be, this will be positive and this will be negative, right? And in the second case the electric field is in the upward direction. So upward direction means this will be the positive and this will be the negative, right? So I am not putting which is positive and which is negative here. While explaining, I'll tell you. Okay, right? So now this is the parallel plate which is necessary for producing the electric field. Okay, right? So let us see. So a ball having a charge q and mass m is suspended from a string of length L, right? So we are suspending a ball from a support like this, right? Let this be the ball for me, right? Suspended from the string of length L, right? So the length of the string is equal to L. Okay, right? And the charge is q. Okay, right? And the mass is m. So when this ball is suspended in between the parallel plates like this, what are the forces, different forces acting on the ball, children, right? One will be the weight mg acting in the downward direction. Okay, right? Now I have there will be a tension of the string, that is your T. Okay, children, right? Then see, it is being suspended in between an electric field. Am I right? So in the first case the electric field is in the downward direction. So as it is in the downward direction, the electric field will be along this direction, that is downward, right? So if the electric field is acting in the downward direction, we know that there will be a downward force on this ball, right? As this ball is being a charged ball q, right? So what will happen? Due to the charge given to the ball will be experiencing a downward direction. That is, a ball will be always experiencing a positive charge will always be experiencing a force in the direction of the field, right? So this ball will be experiencing an electrical force E is E, right? The electrical force will be equal to Q into E, right? So we know, right, from the Coulomb's law and all, we know that the electric field E is equal to force per unit charge. So from this, F will be equal to E into Q, right? So E into Q will be the electric force on the ball. Okay, and that will also be acting along the direction of the electric field, as the charge given to the ball is plus Q. Okay, right? So they have asked you to find the value for the time period T, right? Time period T when the field is in the downward direction, and the time period T when the field is in the upward direction. Okay, right? So first of all, let us apply the field in the downward direction. Okay, children, right? Now, what is the time period of a simple pendulum, children? The time period T of a simple pendulum, we know the formula from 11th standard, that it is equal to 2 pi into root of L by A, right? So L is the effective length and A is the acceleration of the pendulum. Okay, right? So now, what is the formula for acceleration from your Newton's second law? We know that that is equal to force divided by mass of the ball. Okay, right? Now this force is only due to the external forces, because this is your acceleration, not your acceleration due to gravity. So as this is acceleration, the force will be due to the external forces, right? So what are the external forces acting on this ball, children, right? One is the weight mg acting in the downward direction, and another one is the electric field QE, right? Electric force QE acting in the downward direction. So now this force, so this is your net external force divided by mass. Okay, right? So the acceleration will be mg, weight in the downward direction, plus the electrical force, that is QE, divided by m. Okay, right? So now if I separate them and write, what will I be getting? Mg by m will be equal to g plus QE by m, right? So this is the expression for acceleration. So therefore what will be time period? Time period in the downward direction, right? Time period when the field is in the downward direction will be equal to 2 pi into root of L divided by acceleration is equal to how much? G plus QE by m. Okay, so this is the expression for the time period in the time period when the electric field is acting in the downward direction. Okay, children, right? So now for the second case, the electric field is in the upward direction, right? So for that, the diagram will be like this. Okay, so this will be so as I have drawn a separate diagram for you people, I can now put this to be a positive plate and this to be a negative plate. Now the field is in the upward direction, right? So as the field is in the upward direction, this should be your positive plate and this should be your negative plate. Okay, right? So this is from where the ball is being suspended. Okay, right? A ball of mass m, right? You know that the weight mg will be acting in the downward direction. Okay, right? And the tension will be acting in the upward direction. Okay, children, right? So the electric field is from down to up, right? So the electric field is from down to up, right? So what will be the direction of the electrical force, children? The electrical force will always be acting in the direction of the field for a positive charge, no, right? So your QE force will also be acting in the upward direction. Okay, right? So now for the second case, right? This is your first case and this is your second case. When E is acting in the upward direction, what will be the formula for acceleration now? Acceleration will be net external force, right? So what are the forces acting on the object, on the ball? Mg downward and QE upward, right? So this will be Mg minus QE, right? Because it is being directed opposite to Mg. So that's why minus QE divided by m, right? Again, if I rewrite like this, I'll be getting G minus QE by m. Okay, so therefore the time period in when the electric field is acting in the upward direction will be equal to what? That will be equal to 2 pi root of L divided by Q minus QE by m. Sorry, G minus QE by m. Okay, children, hope you have understood.